Good morning. Today's notes is going to be on 3.1 Extrema on an interval. We're going to let F be defined on an interval I containing some C. If F of C is the minimum of F on the interval I, is when F of C is less than or equal to F of X, for all X in the interval. F of C is the maximum of F on the interval I when F of C is greater than F of X for all X in the interval I. Now, a graph can only have one extrema. It can only have one absolute maximum and one absolute minimum. Now, these are also called global maximums. And it can only have one extreme minimum. I'm going to show you some cases. Now this is going to be a closed. Well, actually, let me put it closed up here at -1, 2. So at -1, +2, it's closed. At 0, it's at 1. At 1, I'm going to put it at 1. And at 2, I'm going to put it at 5. 1, 2, 3, 4, 5 up here. Now these are all closed. So right here, the minimum is going to be the bottom. So this right here is going to be the absolute minimum. Up here, that's going to be the absolute maximum. Now, keep in mind, they are closed, so they're included. Same scenario. However, this is going to be open, this is going to be closed, and up here, that's going to be open. If that's the case, this is still going to be my absolute minimum. This is going to still be my absolute minimum because it's closed. However, up here, that's not my absolute maximum because the open circle means not included. So this is not an absolute maximum. Now, right before, like 1.99999, but we can't do that because it's not an endpoint. Now, let's say it looked like this. Where this is going to be closed. Oh, I keep graphing that one wrong. It's -1, +2. -1, +2, that's closed. That's closed. That one I'm going to still leave closed, but right here it's going to be open. Because that's closed at the top, that's going to be an absolute max. Now this is the bottom, the least it's going to go. That would be an absolute minimum. However, because of the open circle, it's not the absolute minimum. So because that's not the absolute minimum, there is no minimum. There is no absolute minimum because it was removed. Now the extreme value theorem states if f is continuous on a closed interval from A to B, then notice how it says closed interval, then f has both a minimum and a maximum on the interval. I'm now going to go into the definition of a relative extrema. Now, on the definition of a relative extrema, basically anything on the bottom or a low point will be a minimum and anything inside will be a maximum. So let's see here. The definition of relative extrema. If there is an open interval containing C on which f of C is a maximum, then f of C is called a relative maximum. So any high point will be called a relative maximum. Any high point will be called a relative maximum of f, or you can say that f has a relative maximum C comma f of C. And the same is going to go for relative minimum. If there is an open interval containing C on which f of C is a minimum, then f of C is called a relative minimum. Of f, or you can say that f has a relative minimum at C comma f of C. Now remember, we're going to have an open interval. So basically, let's say the graph looks like this. Right here, that's not an absolute maximum because up here it continues on and on and on. So on this one, I'm not going to have an absolute maximum or an absolute minimum. However, because that is a high point, that is called a relative max. And because this is a low point, that's called a relative min. You can have multiple relative maxes and multiple relative minimums. All right, let's see how we can calculate these. Example 1. We have to find the value of the derivative at each relative extrema.